Now we have question number 5, which says lamps are made in a factory. A random sample of 50 of the lamps is tested and 4 of them are found to be faulty. So let's underline 4. A total of 4,000 lamps is made in one day. Calculate the number of these 4,000 lamps you would expect to be faulty. So we're going to set up a simple proportion here, and that is that when we test 50 lamps, out of the 50 we have 4 of them that are going to be faulty. So if we test 4,000, how many are going to be faulty? We don't know that, so we'll just put an x here. Now since this is a direct proportion, we'll cross multiply. So 4 times 4,000 equals to 50x. Before calculating the value of x, let's just simplify. So the two zeros get cancelled out. 4 times 400 is going to give us 1600, and bringing 5 on the left hand side means we're going to divide it by 1600. So 1600 divided by 5 equals to x. So 1600 divided by 5, let's simplify this. 5 ones are 5, 5 threes are 15, 1 carry, 5 twos are 10, and 0 carried forward. So 320 are expected to be faulty if 4,000 lamps are made in one day. Now we move on to question number 6, which says Daniel earns $760 each month. He pays 15% of his earnings in tax. Okay, so this is very important. Of the $760 that he earns each month, he pays 15% of his earnings in tax. Calculate the amount of money Daniel has each month after paying the tax. So let's underline the word after. So if he's paying 15% of tax, we can do it. We can solve this question two ways. First, we can figure out what 15% of 760 is. So in order to do that, I'm going to take 15%, which is just 15 upon 100, and multiply it by 760. So let's start simplifying this. First of all, the two zeros get cancelled out. 15 and 10 can be further reduced. Let's use a different color for that. 5 threes are 15, 5 twos are 10. And then I can simplify 2 and 76, so 2 ones are 2, and 2 threes are 6, 1 carried, and 2 eights are 16. So all we got to do is we got to find out what 38 times 3 is. So let's do that. 38 times 3, 8 times 3 is 24, 3 times 3 is 9, 9 plus 2 is 11. So that means he has to pay $114 in tax. Now remember, this amount that we've calculated is the amount that he has to pay in tax. So if I want to find out the amount that he will have left after paying $114 in tax, the way to do that would be to take 760, which is the total amount that he makes, and from it subtract 114. So let's find out what this is going to be equal to. We're going to carry the 1, borrow 1 from 6. 10 minus 4 is 6, 5 minus 1 is going to be 4, 7 minus 1 is going to be 6. So the final answer to this is going to be $646. Now we move to part B, which says Daniel invests $1,200 in a savings account. The account pays simple interest at a rate of 2% per year. Calculate the amount of money in the account after 6 years. So it's important to underline this statement, which is in the account after 6 years. So a common error here would be that students would just figure out the amount of simple interest that is earned and leave it there, whereas we have to figure out the total amount in the account after 6 years. So let's see how to do that. So in order to calculate the simple interest, the formula that we use is simple interest equals to P or T upon 100, where P is for the principal amount that is invested, R is for rate, and T is for time, which is in years. So the principal amount here we can see is 1200. So 1200 multiplied by the rate, which is 2, multiplied by the time, which is 6, and divided by 100. So the two zeros get cancelled out right away, and then we have 6 times 2, which is 12, and then 12 times 2 is going to be 12 times 12 is going to be $144. So the $144 is the simple interest that is earned. Now bear in mind the principal amount is there, so 1200 plus 144 is going to be the total amount in the account after 6 years. So 4, 0 plus 4 is 4 again, 3, 1. So $1,344 is the total amount in the account after 6 years. Let's do question number 7, in which we have to find a fraction that lies exactly halfway between 3 upon 5 and 3 upon 4. So this is essentially like taking out the midpoint. So how do you take out the midpoint of any two values? You simply add them up and you divide it by 2. So 3 upon 5 plus 3 upon 4, we're going to add this and divide it by 2. So in order to add two fractions, of course, we're going to have to take out the LCM, which is going to be 20, or we can just multiply the two denominators. 5 into 4 is 20, and then 3 times 4 is going to be 12, and then 3 times 5 is going to be 15. Adding this gives us 27 upon 20. Now we have to divide this value by 2. So 27 upon 20 divided by 2 means that 27 upon 20 will be multiplied by 1 upon 2, which is going to be equal to 27 upon 40. So this right here is our final answer. Let's just write it in the space that's provided, and let's move on. So now we have question number 8, which is a question related to ratios. It says a drink is made by mixing fruit juice and water in the ratio 3:5. The drink is made using 2 liters of water. Calculate the amount of fruit juice used. Give your answer in milliliters. Okay. So if I were to illustrate this, let's say here's a glass of juice, right? And in it we are mixing it. Here's a glass of the drink that we're talking about, and this is made by using fruit juice and water in the ratio 3:5. So that means the juice in this is 3 parts. So you can say that this part is juice and this part is water. Let's just color this blue, and let's just color the juice part red. There you go. So they're in the ratio 3:5. Now the question says that the drink is made using 2 liters of water. So that means the water, which is going to be 5 parts, is basically equal to 2 liters of water. So the way to do this is very simple. You write juice in one column and you write water in the other. We know that their ratio, according to the question, is 3:5. So if you're using 2 liters of water, so I'm going to write 2 under water, and how much juice will I require? We don't know that, so that's x. Now let's cross multiply. So we have 5x is equals to 3 times 2, which is 6. So x is equals to 6 upon 5. But bear in mind, this answer is going to be in liters, whereas the question wants us to give a final answer in milliliters. So for this, you need to remember that 1 liter is basically equal to 1000 ml. So we're going to have 6 upon 5, and we're going to multiply this by 1000 so that I can convert this into ml. So we start simplifying this. 5 ones are 5. 5 2s are 10, 5 zeros are 0, 5 zeros are 0 again. So 6 times 200 is going to give us 1200 ml. Alright, so now we move to question number 9, which by the looks of it is related to kinematics. So let's start reading the question. It says a car starts a journey from rest, so that means the point from where it starts, the speed is going to be 0. It moves with a constant acceleration for 20 seconds until it reaches a speed of 15 meters per second. Okay, so if you look at the graph and if you look at the y-axis where we have speed, so 15 is going to be exactly halfway between 10 and 20. Okay, so this is the speed that this car will attain after 20 seconds. So that means at this point where I'm marking it here, the speed is going to be 15, and it will take 20 seconds to reach the speed, and it will do this while having a constant acceleration. That means from the starting point till this point, we're going to have a straight line, or you can say we're going to have a constant sloping line. Okay. Then it says it moves with a constant speed. So what happens when an object moves at a constant speed? We know that the speed time graph stays horizontal of 15 meters per second for 40 seconds. So that means adding another 40 seconds to 20 seconds is going to give us 60. So that means for the rest of the journey, let me use a different color for this. So for the rest of the journey, our car, this car, whatever this is, will move at a constant speed of 15 meters per second, and it will do so for the next 40 seconds. Okay, so here we have a speed time graph, and 2 marks are guaranteed for sure. Then it says calculate the acceleration of the car in the first 20 seconds of the journey. So how do you calculate acceleration? In fact, what is acceleration would be a better question. Acceleration is the rate at which our speed is increasing or decreasing, or simply it's the rate of change of speed. So we can see that in the first 20 seconds the speed increased from 0 to 15. So we can see that there's a change of 15, and it did this in a period of 20 seconds. So if I want to figure out the acceleration, I need to take the change in speed, which is 15, and divide it by the change in time, which is 20. Simplifying this will give me 3 upon 4, or if you wish to write this in decimal, decimal value of 3.4 is 0.75. So I'll write 0.75 here, but you can also write 3.4. Nothing to worry about. Okay. Then we have question number 10, which says use set notation to describe the shaded region in the Venn diagram. Okay. So we can see that P and R are shaded, but the part that is overlapping with Q is not. So that means if it were P union R, so this part, the one that I'm coloring in black, will also be shaded, but that's not the case. So that means along with P union R, we need to exclude the region that is lying inside Q. So intersection Q, and since we need to exclude that part, so we're going to put a complement here. So this is the region that is shaded. Alright, now we have part B, which says there's a universal set which contains a positive number, universal set x such that x is a positive number. Now A is a set which contains numbers between 9 and 10, B is a set which contains an irrational number. Okay, write down an element of A intersection B. So we need to think of elements that are in set A and in set B. Alright. So the universal set has all positive numbers, be it integers, be it rational, be it irrational, be it decimal, whatever you can think of. We have those in the universal set. A, however, holds only the numbers that are from 9 to 10. So obviously A is going to have all the decimal values in it. So if I were to illustrate this using a number line, so this right here is my universal set. Remember, 0 is not included, but everything on the right hand side is going to be included. So this is my universal set. We have all positive numbers. Set A contains everything between 9 and 10. So this right here is set A. There you go. 9 and 10 are not included. And B is an irrational number. Okay. So if I want a number that is present in A and in set B, it has to be an irrational number between 9 and 10. So that number can be found in set A and in set B. Irrational number between 9 and 10. Now we can have multiple answers to this. The easiest way of solving a question like this, when you have to write down an irrational number between two integers, is that you rewrite the given integers as their perfect squares, as square root of their perfect squares. So the square of 9 is going to be 81, so that means 9 can be rewritten as square root of 81. 10 can be rewritten as square root of 100. Now anything between these two numbers is going to be irrational. Why? Because you cannot take the perfect, since they're not going to be perfect squares, that means you cannot take the square root of them. So that means we can have anything from starting from square root of 82 and going all the way to square root of 99. So we can have multiple answers to this. There's no point in arguing whether what answer is wrong and what is correct. As long as it's between root 81 and root 100, it is going to be absolutely correct. So I'm just going to write root 85 to be on the safe side. You can write like root 87, root 99, whatever you wish. Okay. So there you have it. This number is irrational and at the same time lying in set A, which is going to be between 9 and 10. Now we move on to question number 11, which is again very easy, and simultaneous equations. So in paper 1, I strongly recommend to all my students to solve simultaneous equations using the method elimination, because it's a lot easier and a lot more efficient. So I'm going to start by multiplying. I've subconsciously decided to eliminate y, and that's the wise choice to make, because we have positive 4y in equation 1 and we have minus 2y in equation 2. So all I got to do is multiply equation 2 by 2. So we have 9x plus 4y equals to minus 5. This is equation 1. After multiplying equation 2 by 2, it's going to become 12x minus 4y equals to 12. Now I'm going to add these two equations so that the y's get cancelled out. Minus 5 plus 12 is going to give me 7. Plus 4y minus 4y is just is going to get eliminated. 12 plus 9 is going to give me 21x. So 21x equals to 7. Let's solve for the value of x, which is going to be 7 upon 21. Simplifying this will give me 1 over 3. So we have the value of x, but remember, this is not the end of the question as yet. We still have to find the value of y. So I'm going to use the first equation to find the value of y. So 9 as it is, in place of x, let's write 1 over 3. Plus 4y equals to minus 5. So 3 1s are 3, 3 3s are 9, 3 plus 4y equals to minus 5, 4y equals to minus 5 minus 3. Minus 5 minus 3 will give us minus 8. So 4y equals to minus 8. Y is equals to minus 8 upon 4. Simplifying this will give us minus 2. So there we have it. We now have the value of y as well. Alright, let's move on to question number 12, which says write these numbers in order of size starting with the smallest. Okay, so if I want to figure out what the smallest number is, since we have different powers of 10, I'm going to look for the power of 10 that is the most negative. So the most negative is minus 5. So this right here is going to be my smallest value, 1.7 times 10 raised to the power minus 5. And then since we have two powers of minus 4, so I can't compare that since they're the same. So I'm going to look for the value that's just before that. So here we have 3.5 and then we have 4.2. So 3.5 is obviously going to be smaller. So there you go, 3.5 times 10 raised to the power minus 4, and then we're going to have 4.2 times 10 raised to the power minus 4. And then we just have one value left, which is 2.1 times 10 raised to the power minus 3. Okay, so that's that. Let's move on to part B. Again, question related to standard form. Evaluate the following, give each answer in standard form. So in part 1, we have to subtract these two. So that means 6 times 10 raised to the power 10 minus 5 times 10 raised to the power 9. Now I've seen a lot of students take an agonizingly painful way to solve questions like these, and that's very inefficient and takes a lot of working space as well. What they do is they open them up and write them as integers and then solve them, integers or decimal. In this case they're going to be integers, but that's not something I recommend. So in order to subtract these two, what I'm going to do is I'm going to borrow. Basically the idea is I'm going to reduce this power 10 and bring it down to 9. So in order to do that, I'm going to borrow one power and give it to 6. So that's going to make 6 60, and then the power will be 9 minus 5 times 10 raised to the power 9. So 60 minus 5, I can easily subtract the two since they both share the same power. 60 minus 5 is going to be 55 times 10 raised to the power 9. But remember, this answer is not in standard form, and the reason for that is the value before power 10 is greater than 10. So what I'm going to do is I'm going to move the decimal one place backwards, and in order to cancel out the effect of that, I'm going to increase the power by the number of places I've moved the decimal. So that's 1. So this is going to give me 5.5 times 10 raised to the power of 10. Okay. Next we have to find out PQ, which means I need to multiply P with Q. So multiplying is fairly simple. 6 times 10 raised to the power 10 multiplied by 5 times 10 raised to the power 9. You can remember this as we multiply apples with apples and oranges with oranges. So 6 times 5 is going to be 30, and 10 power 10 multiplied by 10 power 9 means that I'm just going to add the powers. So that's going to make it 10 plus 9. So 30 times 10 raised to the power 19. So again, remember, watch out that this answer is not in standard form. So I'm going to bring the decimal one place backwards and add 1 to the power. So this is going to make it 3.0 times 10 raised to the power of 20. Now we move on to question number 13, which says expand and simplify. Okay, so how do you open up a bracket that has a whole square? If you remember the identity, a minus b, the whole thing square, is equals to a square minus 2ab plus b square. So in place of a here we have x, and in place of b we have 3. So this is going to become x square minus 2 into x into 3 plus 3 square. So let's simplify this. X square minus 6x plus 9 is going to be a final answer. So let's just write it here. There you go. Factorize. So factorize means that we're going to take common whatever we can. So 18 and 6, we can see that they both have a common divisor, and that is 6. So if I take 6 common, so 6 times 3 is 18 minus y, and in the next pair we can conveniently factor out 5 along with x. So this will make it y minus 3. But there's a small problem, and that problem is that the signs inside the bracket are different. So we can fix this by taking minus 5x common, and in the bracket now we'll have minus y plus 3, which is essentially the same as 3 minus y. So let's just write this nicely. This is going to make it 6 into 3 minus y, and then minus 5x as it is, and then I'm just going to rearrange this and write it as 3 minus y. So this is going to become 6 minus 5x multiplied by 3 minus y. So here we have 6 minus 5x multiplied by 3 minus y. And there you have it. We now have the factorized form of the expression that was given to us in the question.